Hey everybody, it's Mr. Carr again. Today we're going to be starting our new unit on circles. So unit 7, with this one, 7.1 day 1. It's all about just our basic circle facts. So it's a lot of vocab. I'm just going to run through these a little bit quicker, make sure we got these make sure we understand all these terms here. So first thing is, what is a circle? It is a set of all points that are equidistant from a given point called the center of the circle. It looks like this. Let's say I have a center point here, and if I do all of these points around, okay, technically what I'm really doing is I'm doing a bunch of little points that come around, and they're really close together, so they form a line. So we do this curve, so every point is equidistant to the center. Now that distance has got a special name to it. So if I go from the center to the edge, that is called the radius. That's the distance from the center of a circle to any point on the circle. Okay, so again, if I do that, here's my center, here's a radius right here. Now, when I draw in any radius I want, like this one here, they're all the same length. That's what it means also to be equidistant. If we go the distance across a circle through its center, that's what's called the diameter. So instead of going from the center to the edge, we're going to go edge to edge here. So if I just do something like that, but I have to pass through the center. Now notice the diameter, I have two radiuses. I can go from left and right. So that means the diameter is always going to be 2 times the radius. It's because it's made up of 2 of them. Circumference, that is our distance around a circle. So we're always been looking at from the center to the edge or from edge to edge to go across. Now we're looking at the circumference, which is all the way around the circle itself. So for example, I would do this to go all the way around like that. Okay. Central angle, that's an angle whose vertex is at the center of the circle. Okay, so I draw that. Okay, we got a little bit extra music going on, so give me a second here. Okay, sorry about that. So yeah, I was drawing this. Now when I draw this in, here's my vertex is at the center. Okay, so this is the central angle. This is my vertex right here. Notice it's made up of 2 radiuses. That's the other part of that. Arc measure. This is the angle the arc makes at the center of the circle. So an arc measure, if we talk about that, is kind of related to our central angle. So if I draw something in like this right here, the arc measure is this angle. So kind of think of it this way. If I look at the angle, what's the angle between my two hands here? Okay, so if it's like this is about 30 degrees, roughly like that. Well, the arc measure would be from my fingertip to fingertips. What like circular path is that? That's also about 30 degrees. And that's actually something, let me just double check. Yeah, it's not on there, so I want to make sure we're cover this. Just be on the safe side here. Yeah, it doesn't show up here, so let me just mention that right now. So it's important to know that a central angle and an arc measure, they're always going to match up. So for example, let me just draw a little bigger circle here. All right, sorry about that. So yeah, so if I do something like this, for example, here's my central angle. Let's say I made this to be about 80 degrees. The arc measure is also 80 degrees. So central and arc measure always match up. With our arc measures, we can give a little bit more information about them. It's called, we're basically going to look at a minor arc versus a major arc to start. A minor arc is a part of a circle that measures less than 180 degrees. The major arc is between 180 and 360. Okay, so I'm going to draw the same circle twice. Do this here. Yeah, it's pretty good like that. And then let's do, here's A. And I'll put B right here. Let's put C over here. Okay, so this is important how we have this set up because let's see, can I copy that? Close enough. Let's just put the A on there too. Okay, so the minor arc is the shorter one like this, like that's that right there. Okay, so that would be my minor arc. We notate that with like 2 letters and a little arc above that. Okay, the major arc would be, I'm going to use the same letters of A and B as my endpoints, but I'm going to go the other way around. So going from this way all the way here, this would be the major arc. So minor arcs and major arcs are usually related to each other. To notate that, because if I just do AB, that implies the shorter distance. I have to use 3 letters for that notation. So it's ACB. Okay. So anytime you want to do a major arc, you have to do 3 letters. For a minor arc, you just do the 2. So like whenever you see 2 letters, you take the shortest path between the 2. When you see 3 letters, you're going to go the longer way around. And you have to pass through where, like kind of like an angle measure. You have to put that point C in the middle. All right. The other type of arc we can see is a semicircle. This is when the arc has endpoints that are the endpoints of a diameter. And that measure is exactly 180 degrees. So that would be like this one down here. So I look at this one, keep in mind, my semicircle arc, it's exactly 180 degrees. Kind of technically doesn't matter which one I want to do, but let's say if I want to name this one specifically, that is going to be arc ACB. Whereas if I look at this one, that's arc AB. So just use like whatever makes the most sense there. Okay. So some other parts here, we'll get to this later, but the idea of arc length and sector, that is a distance and an area. But that's for the next lesson on that one. But just remember the central angle always matches up to the arc measure here. Okay. And here's another visual, minor arc versus major arc. Minor arcs are always less than 180. Majors are always greater than 180. Semicircles are exactly 180. So, oh yeah, the other part of this too, don't forget, because we're going in a full circle, the measure of an entire circle is 360. Whoa. That's weird. Okay, let's try that again. It's 360. Oh my God, I don't know what's going on here. Okay, the measure is always 360 degrees. Okay, so that's the entire circle. So we can always keep that in mind because let's say we want to find the measure of a major arc. That is going to be the difference between 360 and the measure of its related minor arc. So if I look at something like this, let's pretend that this is, I don't know, this is 80 degrees here on this one. Then the major arc is going to be 360 minus 80, which is 280 degrees there. That would be the long way around for the major arc. Okay. And the measure of a semicircle is always 180 degrees. All right. A couple other things for today. First one is arc addition postulate. So this is just simply stating that the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Okay. This one's not quite very good, but let me add a little bit more on here. Let's say I draw this in here. And that would make this about, let's make it 100, make it 150. That's close enough. So if that's the case, let's say I want to find the measure going from here to here, okay? Because the central angle matches up to what's on the edges here for the arc measures, to go all the way from BAD, then the measure of arc, measure our arc BAD is going to equal to 50 plus 150, which is 200 degrees. Okay, so that's what we're trying to show with this. It's a 2 adjacent arcs. So that one is adjacent to that one. They're just sharing, they basically share an endpoint. So you may find a new bank and divide your money several ways as shown in the circle. Find the indicated arc measures. So for our first one is BD. Again, like I said before, if I want to look at BD as my 2 endpoints, it's always the shorter path because that's the minor arc. So I'm going to look at BD as being these 2. So notice how it comes up from 55 and 105. So the measure of arc BD is equal to 55 plus 105, which is equal to 160 degrees. When I want to do the measure of arc BCD, so that means I'm going to start at the same endpoint, and I'm going to take that the long way around. So that means the measure of arc BCD is equal to 140 plus 60, and that comes out to 200 degrees. Notice I could have done this instead. Since I already have the minor arc, I could have done this, where I take 360 minus 160, and I still get the same thing of 200. Okay, so that's it there. 2 more things today. Circumference and area of a circle. So we brought that up. Well, I brought up circumference. There's a formula for that. The formula for circumference is 2 times pi times radius, or pi times diameter. Because remember, 2 times the radius is the same as diameter. So we can see some writing problems with that. first type is let's find the circumference if we're given a radius of 11. So that would be something like this. If I do circumference is equal to 2 times pi times 11, which is equal to 22 pi. 22 pi on this case is going to be meters. 22 pi actually represents the exact, okay, kind of like when we did our square roots. This is an exact circumference. If I want the approximate, we're just going to plug in the calculator. Okay, I do that and I get 69.12 meters here. The other thing we can do is we can work backwards. We want to find the radius if we're given a circumference. So the circumference is 18. That equals 2 pi r. So I'm going to take this, I'm going to just divide by 2 pi to both sides. When you do this, make sure you're very careful. It needs to look like this when you divide it out. So in my calculator, it's going to be 18 over 2 pi as a fraction. So that radius comes out to about 2.86 yards then. All right. And finally, area of a circle. So this is a two-dimensional area. We're covering up this amount. So real quick, circumference is how far around the circle do I go? That's my measurements are still the same. It's one dimension. It's meters, it's yards. For area, this is going to be square feet, square meters, whatever that is. Okay. Area of a circle is always pi times radius squared. Okay. This is a visual representation of what creates that. But we're going to worry more about these example problems. Okay. So just like the last one, we can do two things with it. We can calculate the area, or we can work it backwards and find a dimension here. So the given radius is 4.2 of this watch. Since area is equal to pi times radius squared, it's going to be pi times 4.2 squared. So I just plug that in my calculator, get a decimal number. I'm going to get 55.42. And this is important. It is square centimeters. It's not centimeters, it is square centimeters because we are finding area now. Here I want to find the diameter of CD, and I'm given the area. So we're going to work this backwards. So if area is equal to pi r squared, that means 201 is equal to pi r squared. I want to divide both sides by pi. So I have 201 over pi is equal to r squared. And then I can undo my r squared by taking the square root. I do that. R is just about 7.99 centimeters. So if that's my radius, remember the question says to find the diameter. So diameter is going to be twice that. So diameter is going to be about 2 times my 7.99, which comes out to 15.98 centimeters. Now keep in mind, it started with centimeters squared. Since I'm finding radius, that's just centimeters. And so that's why we're done with this problem here, or we're done with our labels with that one. And that's pretty close to 16. So if you want to round it out to 16 for a real life scenario like this, yeah, go for it. All right. But that is it for today. So lots of circle facts, a lot of vocab. Just make sure you keep track of all the little details with all that. And then the other parts of it would be arc addition, circumference, and area. Okay. So all these parts of our circles with that. All right. And that's it for today. So take care, everyone.